point that I would like to. Okay. General guideline to find reactions. When you are given a problems where you have loading frame like this, a frame like this with inclined member with the loading acting, I think not in vertical directions and in certain directions. So when you want to find reaction forces, then it is good to find reaction forces in following this global X and Y, which is horizontal X, horizontal Y. So find the reactions following this global X and Y when you want to find reactions. Of course, you can also find reactions. In this direction or in this direction and follow the member. But my advice is, if you want to find reaction forces, then although you have inclined member like this, so find reaction forces following this global X and Y. Find the reaction is global X and Y, okay, like this. Then when you want to calculate shear force, which is for this member, it is defined not in horizontal and vertical anymore, then you have to find the component of the reaction forces, which is in horizontal, vertical, follow the direction of the shear force. So what is the component of this in the direction of the shear force? You must be able to find. What is the component of this vertical reaction force in the direction following the shear force? Then we must be able to find when you want to calculate the shear force in this member. But get the reaction forces following the X and Y. That will be easier. If you want to find this, if the actual force is like this, if for this member the shear is now changing direction, so to find the shear force here in this member, then you need to find the component of this horizontal reaction force following this shear force in this member, the directions. The same thing for this vertical component, vertical reaction forces, find the component following this direction of the shear force S. But again, find reaction force follow X and Y direction, it will be easier. Okay. Then, okay, component of reaction force, okay, or any other point loads in the direction of S. How do we find this? I give you a guideline here. First, you need to know the inclination of this member. That one you can get it from the problem given to you. This is in X direction, this is in Y direction, horizontal, vertical. How to find this component of this in S, component of this in S? You must first know the inclination of this member. This is inclination of the member, okay? So if this inclination of the member is, let's say the angle is this, which is theta here, then from the relationship here, so this is 90 degrees, this must be 90 degrees, okay? This is 90 degrees, okay? This is 90 degrees. This is 90 degrees, okay? So if this is theta, if this is 90 degrees, then we can, from the diagram here, we can find that if this is theta, when you come to this diagram, this must be theta. This must be theta here. And when we come to this diagram here, this force diagram that we draw for this vertical reaction forces here, this is the triangle that we draw for this vertical reaction for us to calculate this component and this component. So this angle here will be equal to this angle, and it will be equal to this angle. So once we know that, then we are able to find this component of this is this one, cos this theta, and this one is this sine theta, and for this one become this cos. This one, this component will be this cos theta, you get this, and this one sine theta, you get to this one. So which is shown here. So if this is AX, this is AY, the horizontal one and the vertical one. then this one, this component, which we need to calculate the shear force S here, it becomes AX sine this theta for this. But for this one, it becomes AY cos theta to get the component which is parallel to S here, which we need to use when we want to calculate shear force in this member. To calculate axial force, then we need this component from AX, which is AX cos theta now. We need this component from AY, which is AY sine theta. AY sine theta. Okay. And this one will be used when we want to calculate axial force in this member. So this gives you a guideline on how to get the AX and how to get the component of forces in the direction of shear and in the direction of Q when we want to calculate the axial force and the shear force in the member. Okay. So I think I will stop here tonight. I think it has been more than 2 hours, so